Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 24 of the quantum mechanics, and also it is second part of the degenerate and dependent perturbation theory, right? So we'll solve some questions and related to degenerate and dependent perturbation theory, and also we'll study Fermi golden rule. Okay. And also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start now. Okay, so I'll start with Fermi golden rule. Okay, Fermi golden rule. Fermi golden rule. Fermi golden rule. Okay, Fermi golden. Okay, so as we have seen, if I have already explained this in my previous lecture. I have already explained degenerate perturbation theory and dependent perturbation theory, right? So you can check my previous lecture. So if constant perturbation, if constant perturbation is applied, if constant perturbation is applied for a very long time, then transitional probability is proportional to transition probability is proportional to t, right? Which I have already explained in my previous lecture, guys, at t tends to infinity, right? T. So if constant perturbation is applied for very long time, then transition probability is proportional to 2. This I have already explained. And similarly, if constant perturbation, if constant perturbation is applied for a very short time, okay, then transitional probability is proportional to t square, right? So we know for very short time, if constant probability is for very short time, then transitional probability is proportional to t square. If it is for long time, then transitional probability is proportional to t, right? This we know. So PFI for long time, okay, PFI is going to be 2 pi t, this I have also derived in my last lecture, 2 pi t upon h cut vfi mod square of vfi delta ef minus ei. Okay, so transitional probability for t tends to 0 for long time. Okay? For t tends to 0, transitional probability is 2 pi t upon h cut mod square of vfi delta ef minus ei, right? This we know. Now if when ef equal to ei, okay, ef equal to ei, in that case delta value of ef minus ei, ef minus ei value is going to be 1. Okay, in this case if ef equal to ei, okay, and then the value of delta ef minus ei is going to be 1. So in this case transition will occur, transition will occur only. So if this is the case, transition will occur only if ei equal to ef. Okay, if ei equal to ef, then transition will occur. Okay, so transition will occur only if ei equal to ef. Okay, so it will represent, so it will represent transition between degenerate energy levels. Okay, between degenerate energy levels. Okay, so this occur, and if so, it will represent transition between degenerate energy levels, because ef equal to ei, right? So it means so transition will occur, okay, between the degenerate energy levels. Okay, well, so I'll start some questions, okay, which were asked in net. Okay, so I'm going to solve one question first. I have already explained transitional probability, right? So this is the question related to transitional probability. Okay, I would request you watch my previous lecture for understanding degenerate perturbation theory and dependent perturbation theory. Okay, so question is, which is asked in CSIR net December 2016. Okay, so it is asked CSIR net. This is the question of December 2016 question. Okay, so question is, a particle of charge q, a particle of charge q, meanwhile just let me check whether I'm audible or not, because many times I've faced this difficulty, so I check it. And also I would request yes, I'm audible. Okay, so a particle of charge q in one dimension is in a simple harmonic potential, with angular frequency omega angular frequency omega, it is subjected to a time dependent time dependent electric field so it is subjected to a time dependent electric field, that is ET, E which is function of t is a e to the power minus t upon tau whole square, where a and tau are positive constant are positive constants, and omega tau greater equal to 1 and omega into tau is greater equal to 1. Okay, if in the distant past if in the distant past t tends to infinity, the particle was in its ground state the probability that it will be in the first excited state as t tends to plus infinity is. Okay, options are okay, excited state as t tends to 0 proportional to number A, omega tau square, option B is e to the power half omega tau whole square, option C equal to 0, and option D is 1 upon omega tau whole square. Okay, so this is the question, guys, and question is very good question, and it is asked in 2016 December. A particle of charge q, so there is a particle of charge q which is in one dimension in the simple harmonic potential, okay, with angular frequency is omega. It is subjected to a dependent electric field. Okay, so electric field is given there, electric field is applied there. Okay, and where a and tau are positive constants, and omega into t is greater equal to 1. Okay, if in the distant past when t tends to infinity, okay, minus infinity, particle was in its ground state. Okay, the probability that it will be in the first excited state as t tends to plus infinity, okay, is proportional proportional to. Okay, so that probability you need to find out, that is transitional probability. Okay, well, so I'm going to solve it now. So we have been given, that is ET, the electric field is given. Okay, so that is A e to the power minus t upon tau. Okay, A e to the power minus t upon tau whole square. A e to the power minus t upon tau whole square. Okay, so this is given. Okay, and this value is, guys, h dash fi. Okay, this is the value of h dash, this is the value of h dash fi. Okay, and omega fi value we know, right, from this is the ef minus ei upon h cut, right, and this value is going to be so this is E final is ground is for simple harmonic oscillator, so E1 minus E naught upon h cut. So this is going to be, we know, so first excited state harmonic energy is 3 by 2 h cut omega, right, 3 by 2 h cut omega minus 1 by 2 h cut omega for ground state upon h cut, right, and this value is going to be omega. Okay, h cut is going to be cancelled, and 3 by 2 omega minus 1 by 2 omega, that value is omega. Okay, so we have got value of omega fi and h dash fi, right. So now we can use the transition probability formula, right. So now we know that transition probability, that is pfi or p10, this is going to be mod square of cfi, right. So cf, first we will find cfi. Cfi value is minus iota upon h cut, right, cfi minus iota upon h cut integration 0 to t, this is the formula, 0 to t h dash fi into e to the power iota omega fi t or t dash dt dash, right. This is the formula, guys, right? CFI formula. You need to note down. I have already explained it in my previous lecture. So CFI value is going to be minus iota upon h cut, be in excited state, right? First excited state. So this is going to be a h dash fi value is, we have already given, right? This is a e to the power tau t upon tau whole square, right? So this is going to be a e to the power minus t square upon tau square, we can write, right, whole square means, and e to the power iota, very easy question, iota omega t dt, right, because omega fi value is omega, right. So we'll proceed further, right. So this is going to be CFI equal to, now we know the formula, guys, here, right, e to the power minus ax square value, right. This is root pi upon a. I have already explained in my quantum mechanics class, mathematical classes as well. Okay, so this is integration, this one 0 to infinity. Okay, this value we know, integration 0 to infinity e to the power minus alpha x square. I just so in my previous lecture I take just half an hour ago. Let me just check. Yeah, I have taken mathematical physics class, right? This formula I have explained there. So this is e to the power minus alpha x square plus beta x, right, dx. This value is, we know, that is pi upon root pi upon alpha e to the power 2 minus beta x, beta square e to the power beta square upon 4a e to the power beta square means beta square e to the power beta square upon 4 alpha, right? This is the formula. So we are going to use this formula. Okay, so here this is going to be minus iota upon h cut integration 0 to infinity. Okay, so this is a, and we can write this e to the power minus t square upon tau square plus I omega t, right? This is e to the power alpha x square plus beta x, right? This is in this form, right? Where beta value is I omega and alpha value is 1 upon tau square, right? So now we'll use this formula directly. So value of CFI is going to be minus iota upon h cut. Okay, a will take outside, and this is going to be, we'll use the formula, right? So this is going to be a root pi upon 1 upon tau, right? Pi upon 1 upon tau square, right? 1 upon tau square is beta square. So minus e to the power beta square. Beta square means I square omega square. So CFI value is going to be minus iota upon h cut. This is a, and this value is going to be root pi tau because the root it is square, right? So it will be out of root. So tau e to the power exponential, we can write ext, and this value is going to be I square is minus, and this value is going to be minus omega square tau, this is tau square, right? Omega square tau square by 4, right? Omega square tau square by 4. This is the one. Okay, so therefore probability is going to be PFI, that is mod CFI whole square, right? So PFI value is going to be this is going to be I square 1, right? So this is mod of c square. So this is going to be a square upon h cut square pi tau square, okay, e to the power minus omega square tau square upon 2, right? Because it is going to be whole square, right? So e to the power omega, so we can write this omega this one, right? Omega square tau square upon 4. So this is going to be like this, omega square tau square, this one, okay? And it means, this implies PFI value is proportional to e to the power minus omega square tau square upon 2. So which option is matching, guys? So option A is matching, right? Option A is matching, this one. The value is minus 1 by 2 e to the power omega tau whole square 1, guys. Okay. Well, so this is the answer. Next question is question 2. Question 2 is very good question, guys. Okay, I'm going to solve it. It's a lengthy question, but we need to solve it. Okay, so this question is a particle but very a particle of mass m, a particle of mass m having charge E confined to a 3D cubical 3D cubical box of side 2A is acted on by an electric field E equal to E naught e to the power minus at and t greater equal to 0. Okay, calculate the probability that the charged particle in the ground state at t equal to 0 is excited to first excited state by time t equal to infinity. Okay, so question is very good question. A particle of mass m having charge E. Okay, so there's a particle of mass m whose charge is E confined in 3D cubical box, okay, of side 2A is acted on by an electric field, okay, E equal to E naught e to the power minus at, t greater equal to 0. Now calculate the probability, okay, probability that the charged particle in the ground state at t equal to 0 is is excited okay, is excited to first excited state by time t equal to infinity. Okay, so this is the question. Okay, so this is also transition probability related question. Okay, so the limit is 0 to infinity, right? So at t equal to 0 it is at ground state, and and uh, and is excited to first excited state by t equal to infinity, right? So now we are going to solve it. The solution is, so first you need to know that this is a cubical box, right? And the wave function for one dimensional infinite cubic box, we know, right? That is psi nx ny nz, right? This value we know, right? Which is 2 upon root 2 upon 2a sine pi z upon 2a. So this is the wave function, right, guys? So we can simplify it. This value is going to be 2 will get cancelled, this one, right? This will cancel with this will cancel with this. So this value is going to be 1 upon root a cube, 1 upon root a cube sine nx pi x upon 2a sine ny pi y upon 2a and sine nz pi z upon 2a sine nz pi z upon 2a, right? So this is the wave function. Okay, now ground state, we know ground state for 3D infinite cubical box, we know that ground state, right? Ground state is 1 1 1, right? And first excited state for it, first excited state is this one, 2 comma 1 comma 1 and 1 comma 2 comma 1 and 1 comma 1 comma 2, right? So these are the first excited state, right? Now ground state energy, you know, ground state energy, that is E triple 1, that we know, right? 3 pi square h cut square upon 2 m 2a square, right? This value we can say E, so this is 3E value. Similarly, first excited state energy, that is E211, right? Or E122 or E121 or E112, right? This is going to be 6 pi square h cut square upon 2 m 2a whole square, or this we can write 6E, right? Where value of E is pi square h cut square upon 2 m 2a whole square, right? Similar case here, right? So these are the first excited state energy, and that is ground state energy, right? So now we have been given electric field. Okay, we have been given electric field. So electric field is given, so that is electric field is given, that is E equal to E naught equal to E naught e to the power minus 18, right? So here we can find h dash equal to the perturbation, h dash equal to f dot x, right? So value of f dot x is going to be minus EEX. Okay, so E value is this, so we'll put the value. So this value is going to be minus E naught x e to the power minus 8, right? This is the h dash value, guys. Okay, and also omega fi, we can find omega fi equal to E2 minus E1 by h cut, right? So this value is going to be this, E2 is 6E this is E2 first excited. E2 is 6E upon 3E by H cut. So this value is going to be 3E upon H cut. This is the omega Fi value, right? So because we are going to find transition probability. Okay. So now there is a lengthy integration here, guys. Okay. So I'll explain that. So this is, so therefore PFI value, we know that, right? This is going to be mod square of CFI, right? CFI, mod square of CFI. Okay. So this value is going to be 1 upon H cut square mod square of integration 0 to infinity H dash Fi e to the power minus omega Fi t dt, omega Fi, okay, minus omega Fi t dt or mod square, right? This is the value of EFI. Okay, now HFI, value of H dash Fi. These are going to be 1 H dash. So this one we know, right? This is this value is going to be H dash Fi value is going to be I H dash F, right? This is going to be here. So here one more thing I would like to, here we can write this in CAD form, right? So this we can write like 1 1 1 state, okay, and this we can write 2 1 1 state, and we can write 1 2 1 state and 1 1 2 state, right? These things. So here this is going to be iota. This we can write, this is the states, right? For this 1 1 1 H dash 1 1 1 H dash, and this is 2 1 1, and similarly this value is 1 1 1 H dash 1 2 1, and similarly this value is 1 1 1 H dash 1 1 2. Okay, so these are the states. So we'll find these value one by one. Okay. So this is going to be, so 1 1 H dash 2 1 1. Okay, so this we will find out. So this is going to be 1 1 1. H dash value is minus E naught minus E naught x e to the power minus 80 2 1 1, right? So this value is going to be, so this value this is constant for, right? So we can find that this value is C. We can take outside C upon, let's see this value is C. Okay, A cube C upon, we can write C upon C into integration 0 to 2a, right? 0 to 2a, and this is going to be psi 111 into psi 211, right? This is going to be C upon, I'll put the value directly. So 1 upon 3, 1 upon a cube 0 to 2a. Values are already I have written. So this is x sine pi x upon 2a sine pi y. This is lengthy question, guys. Y upon 2a, because there is a lengthy integration. So sine pi z upon 2a into sine 2 pi x upon 2a sine pi z upon z and sine So x is also there, right? X, because here x, these are constant, x is all only the variable. Okay, so x is here. So sin pi x upon 2a, sin pi y upon 2a, sin pi z upon 2a. Then sin 2 pi x upon 2a, sin pi y upon 2a, sin pi z upon 2a, and then dx dy dz. Okay, so this is going to be c upon a cube. Okay, integration 0 to 2a x sin pi x upon 2a into sin pi x upon a. Okay, then integration 0 to 2a sin square pi y upon 2a dy, this is dx, and integration 0 to 2a, this is sin square pi z upon 2a dz. Okay, so if you solve it, so this value is going to be 1 1 h dash 2 1 1. So this value is going to be this value is going to be c upon a cube minus 32a square. Okay, 32a square upon 9 pi square into 2a by 2 into 2a by 2, right? 2 will get cancelled, a square, a to the power 4. So this value is going to be 32a e naught e to the power minus 80 upon 9 pi square. Okay, so this is the integration, guys. You can solve it. Similarly, if you find the 1 1 h dash 1 2 1, this value is going to be 0. You can check it. And similarly, if you find this value 1 1 h dash, it's a very lengthy calculation. Okay, so this is 1 1 2. This value is going to be 0. So we'll consider only this value. Then transition probability formula I will put. EFI is going to be 1 upon h cut square mod of integration 0 to infinity h dash fi e to the power minus omega fi t dt mod square, right? So this value is going to be 32a e naught e upon 9 pi square h cut whole square. Okay, and this integration is going to be, this is the integration, right? And this integration is going to be, this is the mod, and then this is the integration, right? This integration, this value, so this is this one, and then mod square of integration 0 to infinity, we'll put the value. Okay, s dash value we have put, right? So e to the power minus i omega t minus 80, right? Because this is the value of h dash. Here e to the power 80, right? So this will be constant, this is the one, right? So this is going to be right, and this mod square, right? So if we integrate it, so this is going to be 32a e naught e upon 9 pi square h cut whole square, and if you integrate it, right, very simple integration, and this is the one. So this is going to be, we will take common, so this is going to be 1 upon omega square upon plus a square. Okay, so this is the answer, guys. Okay, so little bit, but it's a conceptual question, very good question, but there is a lengthy calculation of integration, guys. These values, you will check it, these values are so. Okay, well, so next question, I would request you to So practice these questions, revise these questions, guys. Then you will be able to solve these questions quickly. These are lengthy questions. This question is actually lengthy because there is a huge the integration is tough. Okay, so well, very easy one now. Next question. Next question is question 4. This is for 1D harmonic oscillator. For 1D harmonic oscillator. For 1D harmonic oscillator, that is Vt equal to x e to the power minus t upon e. T upon tau, my apology, t upon tau. Okay, what will be the transition probability what will be the transition probability such that the first particle will transit from ground state to first excited state. Okay, options are number A 1, number B 1 upon 2m omega h cut, 1 upon tau square plus omega naught, and option C is 0, and option D is 1 upon m into 1 upon tau square. So this is 1 upon tau square plus 1 upon omega naught square. Okay, so this is the one. Yeah, this is 1 upon tau square omega naught square. Okay, so now this is the question. Okay, question is for a 1D harmonic oscillator. So we are talking about 1D harmonic oscillator. Vt equal to given x e to the power minus t upon tau. Okay, what will be the transition probability such that the first particle will transit from ground state to first excited state? Okay, from ground to first excited state. Okay, so we need to find out the transition probability. Okay, so we know the formula, right? This is PFI. This value is mod square of CF mod square of CFI, right? So this is going to be, we know that is the value is 1 upon h cut square integration mod square of integration 0 to infinity psi f v psi I, okay, h dash fi, right, e to the power minus iota omega fi t dt mod square of, right, iota is also there, right? Okay, so PFI is going to be, and this is mod square. Okay, so PFI is going to be we'll write it. So this is 1 upon h cut square. So first we are going to find this one. This is, you can call it equation number 1. Okay, so first we'll find this this one. Okay, psi f v psi I. Okay, that is h dash fi, right? This value. So this is a harmonic oscillator, guys. So for that it is going to be psi f is 1 for first acceleration, 1 v 0, right? So this is going to be 1, and we'll put the value of v. V is x e to the power minus t upon tau and 0, right? So this e to the power minus t upon tau will be common, we'll take outside, and this is going to be 1x 0, right? This one, and this is going to be 1x 0. So this e to the power minus t upon tau will take common, and this we know, right? The value of x, expected value of x. So this is going to be root h cut upon 2m omega. The value of x is, okay, 2m omega, and 1 into a dagger plus a dagger plus a 0, right? This is the value of x, guys. A, right? So this is going to be e to the power minus tau upon c root h cut upon 2m omega. Okay, 2m omega, or omega naught you can write. So I'm just writing omega. So this value is going to be, right, this we know how to operate it, right? So this is going to be this value is going to be like 1 a naught one a dagger 0 plus 1 a 0, right? So this value is going to be 0, and this value is going to be 1. How? I'll explain. So this is we know, right? A dagger n, this value is going to be root n plus 1 n plus 1, right? And a n value is going to be root n a minus 1, right? This value we know. So here we'll use the same thing. So this is going to be this root 1 value is 1, and a dagger to do it. So this is going to be 1 then and this is going to be 1 0 plus 1, right? This is going to be 1 1, right? This is going to be 1 into 1 minus 1. Okay, so this value is 0, this value is 1. So the value of 1v not 1v 0, right? This one, this value is going to be, or s dash fi is going to be, this value is going to be e to the power minus t upon tau e to the power minus t upon tau root h cut upon 2m omega, okay? So this is the V naught. Now we can find transition probability. EFI, or we can write E10 from first excited state to ground state. So this is going to be 1 upon h cut square, and this is going to be h cut upon 2m omega, right? So this is whole square, right? So h upon 2m omega, and mod square of integration 0 to infinity, okay, e to the power minus t upon tau e to the power iota omega t dt mod square, okay, this one. Right, so this value is going to be 1 upon h cut will get cancelled, right? So this is going to be 1 upon 2m omega h cut. This will get cancelled, okay. So this is going to be this value mod square of this value, right? So it is going to be integration 0 to infinity e to the power minus e to the power minus, we can write 1 upon tau minus iota omega and dt or mod square, right? We can write like this: iota 1 upon, this is the a, right? This is an outside t, okay. So minus iota, so will not take iota common, just minus will take common, okay. So this value is e to the power minus 1 upon tau, minus we have taken common, 1 upon tau minus I omega t, okay, and dt mod square. So this value we know, right? So e to the power minus alpha t, this value we know, right? So this value is going to be 1 upon 2m omega h cut, okay, and this we can write mod square of this, right? So this value is going to be 1 upon 1 upon uh, 1 upon alpha 1 upon tau square plus omega square minus I omega square, right? But this is going to be minus iota square is plus 1, right? This one. This is the answer, guys. So which option is matching? 1 upon 2m omega h cut into 1 upon tau square plus omega square. Option B is the correct option, guys. Okay. Well, these are the questions, guys. So in next lecture, we are going to, so I will discuss scattering, guys, in quantum mechanics, okay. So I'm going to discuss scattering in detail. We'll solve some questions also related to scattering, and then Born approximation, and after that there is relativistic quantum mechanics, right? So I'm going to complete the quantum mechanics. Okay, I hope before 25th of April I will be able to complete quantum mechanics, and then I'm going to start condensed matter physics, okay. And meanwhile my mathematical classes are also going to be completed, right? And then I will start teaching thermodynamics and statistical mechanics, okay. So these two courses are going to happen in parallel, okay, as quantum mechanics and mathematics are going on at the moment, okay. Well, also guys, I would request you, please, who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science, okay. So now in next class is going to be, I'm going to solve 2019 PYQs of December, okay. Okay guys, thank you, bye now.